In this video, we are going to see about the storage cell or memory cell involved in random access memory, that is RAM. So basically, this RAM is a volatile memory. That means it can store the bit information for temporarily. So when the power off, it lost its stored values. So that is known as volatile memory. But that read-only memory, that is ROM, that is a non-volatile memory. It stores the values. So what are the values inside its ROM? It permanently stores its value. So for the storing purpose, we have two operation. One is write and read operation. We can see this operation in detail. So first consider write operation. So this is your storage cell involved in RAM. So it uses flip-flops, SR flip-flops for storing purpose and some logic gates. So first consider write operation. So that time your write signal here is 0 and this select line is always 1. So this 0 given to this AND gate. So any one of the output, any one of the input of AND gate is 0, your output is always 0. So this state of write operation block the stored value of this flip-flop here. So whatever the value comes here, it just hold in this place and always this AND gate output is 0. That is the entire output of this memory cell, that is always 0 for write operation. So at that time, this 0 goes here. This is NOT gate. So this 0 become 1 here. So this 1 given to both AND gate here. So it got 1 and this also got 1. Similarly, this select line also given to this AND gate. So this also become 1. So this state both AND gate having 2 input 1. So the output of this AND gate decided by this input signals. So what are the values comes here, it just pass that value to this output side of this AND gate. So now consider your input is 1. So this given to one NOT gate and this becomes 0. So now you got one input for all one input for this AND gate, and this here 1 0 1 is the input of this AND gate. So we will get 0 1, that is it just pass the input this side to this side now. So this flip-flop now getting input. So this is SR flip-flop. For SR flip-flop, S is equal to 1, your output is 1. When OR is equal to, that is reset is equal to 1, your output is 0. When set is equal to 1, your output is this Q value is 1. So now your set value is 1. So we get flip-flop value is 1 now. So this value stored in that flip-flop. So we cannot read this value until this write operation is happening. So nothing but this write operation, in this write operation we just load the value. What are the input corresponding value stored inside this flip-flop. So second one is read operation, and this read operation, your read value become, this value become 1. So now this AND gate getting 2 1. Okay, then this 1 is given to this NOT gate, so this becomes 0, and the same 0 given to this AND gate. So now this AND gate getting 1 0 all the time. So any one of the input of this AND gate is 0, always we will get 0 here. So this one from select line. So now consider your input 1 0. So this will get the input of 1 0 0. This one is 1 1 0. Anyway, we have any one of the inputs of this AND gate is 0. So always output is 0 here. So 0 0, the state, the 0 0 is the input of this flip-flop, SR flip-flop. It just hold its previous value. That is a holding value. For this bit combination, this flip-flop hold its previous value. So the previous value for writing operation, it store the value is 1. So we will get 1 here now. So all the input of this NAND gate is 1 here, 1 now. So we can just read the value of this flip-flop now. So the output now is 1. Similarly, for the remaining input combination, if you having 0 here, this time you can read that 0 here. So this is known as read operation. So this way, by using write and read operation, you can store the value and also you can read the stored value.